everyone, this is Night Maven. Today's topic is network as code. Let's first talk about what is VXLAN. Okay, we're focusing here is Nexus Dashboard. The VXLAN stands for Virtual Extensible LAN. Think of it as a way to stretch your network across different locations, like connecting multiple data centers or cloud environment. Okay, this is without being limited by traditional VLANs. Here's the gist. Normally, VLANs work at a layer 2, which is the switching level, but they have limits, like only 40 196 VLANs and issues with protocols like a spanning tree. VXLAN here solves this by just wrapping Ethernet frame inside UDP package, kind of putting a letter in an envelope. We have Ethernet over UDP. So they can travel over the layer 3, which is the IP network. So that means you can create big flexible network that scale better. Why this is useful? It's perfect for large data center or cloud setup, and it helps overcome this VLAN limits and makes the network more scalable, right? So what is Cisco's role? Cisco makes the VXLAN easier with the Nexus Dashboard. It is a central tool. We can create VXLAN. We can monitor the performance, and we could do a lot automation. The infrastructure as a code, we call this the IAC, and plus the VXLAN means managing network like a software. You write a configuration and code, version them, and deploy consistently. For VXLAN, it's a huge because it has two parts. It has the underlay, which is the physical layer. Okay, you got and its overlay is what we have is the VXLAN virtual network, and it's hard to manage. It's a huge automation makes us managing these easier and less error prone. The Cisco supports this with the API. We call it in the Nexus device, it's called NX API. All right. And Nexus dashboards, so you can script and automate everything. That's IAC plus VXLAN. So bottom line, VXLAN equals a scalable virtual network over IP equals to a automated and managed VXLAN like a software. The Cisco Nexus Dashboard is your control center for all of it. Now, what is a Cisco Nexus Dashboard? Think the Nexus Dashboard as your control center for the data center network. It helps you manage everything in one place with automation and monitor and analytics So you don't have to juggle multiple tools. Why do we need it? Because the data center network are getting more complex and spread out. So there are tons of device configurations, data flying around. Nexus Dashboard makes it simple and faster to keep things running smoothly. So some key benefits is a one platform for everything. It manages both ACI and an XOS. These fabric from a single dashboard, no more hopping between tools, and is smarter with AI. It has built-in AI helps with troubleshooting, performance, and optimization. It even has a AI could have AI assistance. Okay, this to speed things up and automate things easy, very easy. And automate the task, use infrastructure as a code, IAC, and deploy these changes faster with just few mistakes. And it gets better visibility. It sees how your network is performing, track energy usage, cost, even emissions. So it gives tips to improve uptime and sustainability. And it also to stay compliant, keep the things secure and integrate with tools like we have this Splunk. Okay. So give a summary. It means you manage a network like a software network as a software. And why is the configuration as a code? Conf is a code. And it validates these changes before deploying so they will get a few errors and deploy consistently and quickly. Again, network as a code, NAC, for Nexus Dashboard is all about managing a network, like a software using infrastructure as code. It builds on a Ansible using Cisco DCNM Galaxy collection. Here's what it means. Cisco provides the Ansible collection on Ansible Galaxy. All right. And this collection includes modules and roles that you automate manage configuration on Nexus dashboards. NAC interacts directly with DCNM Galaxy collection to make automation smooth. It's the easiest way to get things going using Cisco example repository. It has right folder structure, all the files you need, and it gets the details or README with step-by-step instruction. Basically, you clone the repo and follow the guides, you are ready to start automating your network configures. Server, and to access the terminal, we're going to click the menu icon on the top left, and we're going to select the terminal. New terminal. This will open the terminal window at the bottom of the code server interface. The network as code capabilities utilize the Ansible as its code automation engine. To effectively use Ansible with Nexus Dashboard, I will need to set up an Ansible collection that contains the necessary modules and plugins for interacting with Nexus Dashboard. Running the capability requires a working environment that includes Ansible, Python, and the necessary dependencies. will guide you through setting up the environment to run NAC, NX, VXLAN, and Nexus Dashboard capability with a focus on the included this lab environment. When I wish to run Ansible and I should set up a Python environment to work with it. In a computer running Python, I could just install everything at a system level, think as if I I was installing an application for everyone in the system, or I can install it by creating what is known as a virtual environment. Installing Python as a system level may lead to many potential pitfalls and errors. For this reason, it highly recommends just to use tools like PyInv to manage my Python versions and virtual environment. The Python virtual environment allows for easy packaging of requirements that specific Python code needs to run. So for example, I can install different versions of Ansible in different virtual environments for different Ansible executions on my computer. And I could have some automation that I know works with a specific version, and I want to ensure execution every time it runs without issue. First, set up using PyInv to install the version of Python that I wish to use. So in this case, I will be installing the Python 3.12.10, and it's the version that is used in this lab, and it is version that is used in Ansible content that I will be using. So due to the fact that this downloads and compiles Python, we have come uh, I have completed this ahead of the time. So the commands would be py-inv install. So it tells me they already exist. Many documents online will help you install the py-inv on the system. Uh, could be Mac OS, Linux, and Windows. There's also we have many official documents for this. So the first time create a Python virtual environment. So create virtual environment using PyInv with Python version I installed. So this creates a new virtual environment named NACND using the Python 3.12.10. And the pyinv local command set the local Python version for current directory to the specific virtual environment. This allows the automatic activation of the virtual environment when I navigate to this directory. So pyinv virtual inv 3.12.10 create a name nd NACND. All right, and pyinv activate NACND. The second step is to update the pip. The pip is a package manager for Python that allows us to install and manage the Python packages. It is recommended like just to update the pip to the latest version before installing any packages. We'll say pip dash dash upgrade pip. So with this, I can proceed to install what is needed for network as code Nexus Dashboard. Then I will be installing Ansible core instead of just Ansible. The reason I am installing core is to get the granularity of control or Ansible version I'm using. So Ansible Core is a minimum version of Ansible that includes only the core functionality without any additional plugins or modules. This is useful for ensuring capabilities with Nexus dashboards and the specific Ansible collections that I will be using. So pip install Ansible core. The version is 2.17.10. All right. Ansible, next step is Ansible install the Ansible linter. Ansible lint is a tool that checks Ansible code structure for best practices and potential issues. It is very useful when working with everything Ansible. Many of the work I will be doing with Ansible is hidden, but it will be of assistance in areas that I will see shortly. All right. So pip install Ansible lint versions 24.10.0. Then last step to set up the list lab is a JMAS path. JMAS path is a query language for JSON that allows us to extract and manipulate data from JSON documents. It is used by Ansible to parse and filter JSON data. The version we'll be using is 101, which is compatible with the Ansible version we're using. Pip install JMES path equals to 101. All right, then we're going to step forward next, set up NAC network as code for VXLAN Nexus Dashboard. So the best method to start to working with the network as code Nexus Dashboard is to clone our example repository. This repository contains the proper directory structure and the base file required. In addition, the team updates this repository to match with releases so that I get correct the combination of versions for execution. So Ansible um, setup. This is for network code VXLAN next dashboard. I will clone the repository, then set up the Ansible for network as a code VXLAN next dashboard. So this includes setting up the Python virtual environment. I will install necessary packages, which we have already done, and configure the Ansible to work with Nexus dashboard. Before we extract the example repository, we need to understand how the network as a code next dashboard repository contains a series of tags to match the version requirements. So each release version of the capability is tied to specific version of components. In some releases, breaking changes that are introduced that require different versions of a specific package. In the example, uh, we can find a different tags like 043, 042 that are available. The reason it is important is to avoid issues where changes to pushed into the main branch of the example repository may not work with the other components since it is non-tested combination. So the tag is an immutable construct inside of a Git, which means that once a tag is created, it will always point to the same commit, which is exactly the same code. It can't be changed. First step, let's clone the example repository that contains necessary files and configurations for Nexus network as code VXLAN Nexus board. Nexus Dashboard. Using the git command, I will be doing a clone of example repository into directory named this um, nacn-nd in my home directory. So cd network as code, again, git, well, clone, depth1, branch where I wanted the tag 043 HTTPS, github.com, net as code, sabo dc vxlan example, next, and okay. Once completed, I should be seeing the structure inside of my IDE is here. After cloning the repository, I will need to remove the git directory. This is because I will be using this repository as the starting point for my own network as code VXLAN in the project. We provided this example like a repository as a starting point, but I will not be using this repository for myself. So when I delete the git directory, I will no longer be able to use the git command to manage the repository until the repository has been initialized again. So which I will do later. Um, so cd can remove the git. Okay. Then with commands the pyinv local -nd, I will set up the local Python version for current directory to the specific virtual environment. This allows the automatic activation of a virtual environment when I navigate to this directory. While I already activated the virtual environment in the previous step, it is a good practice to set up the local environment for the directory I'm working in. Um, in this ensures that any Python command that I run, this directory will use the correct virtual environment. cd and pyinv local -nd. For next step, when I have virtual environment operational requirements for Python packages that are then stored inside the virtual environment. So this allows me to have different versions of these requirements installed on the same computer without interfering with the other project. In the case of Nexus, so in the case of a network as code VXLAN ND, I define specific versions of Ansible and other packages that are known and tested to work in combination with network as a code VXLAN ND capability. So these requirements are included in the requirements file that is shared as a part of a cloned repository. Okay, take a look. Here you go. In addition, we must also install two packages as part of the network. Code is NAC validate, NAC test. All right. Um, we want to pip install. We want use requirement file. The Ansible collection requirements are defined in this file, yum file, request yum. This file specifies the Ansible collections and plugins that are required for the network as a code. We extend Nexus Dashboard compatibility. I can do is Ansible Galaxy collection install these require yum collection. Then set up the Ansible config file. I will be setting up the Ansible.cfg file. This file is used to configure the Ansible's behavior and the settings. The configuration file is located in the roots of the cloned repository. The file doesn't exist, so I will create it. You will be using some special commands with the code server to set this up. So code server Ansible config. Once the file opens in the code server IDE, I will add the content. Here you go. Save. Once added, we'll save the file. Ansible, let's verify Ansible installation. I should see 2.16.3. Let me explain the file structure. The host val directory has a completed data structure of the network as called data model. The group vals directory contains the general information that is utilized to connect Nexus Dashboard. So in this case, I will have a group called ND that contains the configuration for Nexus Dashboard. In addition to the host vals and group vals directories, there are also an YAML. Inventory YAML. This file is used to define the inventory of hosts that Ansible will manage. So in this case, it will contain the Nexus dashboard as a host. Inside of some of these files, there are references to the environment variables. Okay, so this file read environment variables to pass the configurations, credentials, collection details securely to playbooks without hard coding the sensitive information in the repository. All right. To set up the environment variable, I will need to create an .in file in the root of the cloned repository. The file will contain the necessary environment variable for connecting to Nexus dashboard and executing the automation. So this file is not committed to the repository, so I will need to create it manually. And it will also ignored by Git on the purpose to make sure that I don't accidentally commit sensitive information into the repository, right? Let's say code server will create this in file, paste it in, save. the file. The data model in network as code is structured data in YAML. So that is read by the automation engine. Inside the automation engine is a Terraform or Ansible. The data for a model is read and the parameters that are passed into specific modules and resources. So this is an example how a Terraform resource that reads the value from the data model. So one of the reasons that we perform validation against the data model is to ensure that when automation execution runs, the data that automation engine is going to read is correct. For Ansible, the process is similar but more difficult to visualize in a single image as more steps are involved. When we talk about the infrastructure as code, data model represents the declaration that the network operators want to achieve. So I declare the intent of configuration of network, and it is the job of underlying automation engine to translate the data model information into actual configuration that push to the network devices. This has the benefits of allowing the network operator to simply declare how the network should be configured instead of having to uh, write the code to perform the action. Since we utilize the virtual switches for this lab, we'll not be using POAP, Power On Out Provisioning feature of Nexus Dashboard. Uh, POAP is a feature that allows the automatic provision of the switches when they are powered on. In real-world environments, you would use a POAP to automatically provision the switches in the fabric. Now, we have a basic understanding of the data model, and we build the data model for lab environment that we're using. So the repository that was cloned in previous section contains a starter data model that I will use. The next set of dashboards requires serial numbers of switches that will be managed. This is important for automation to correctly identify and manage the devices in the fabric. The serial numbers that are typically obtained from the device itself. In real world environments, I would obtain the serial number from the customer or the web order itself, PO. The information might come in form of a spreadsheet or CSV file, which I would then have to parse or extract the relevant serial numbers, such as we can place them in the data model. When working with virtual switches in the CML, the serial numbers change with every fresh development. So I will need to obtain all serial numbers from the switches. So we are building a data model using CML topology. We have included a small script to go read all the serial numbers from the fresh topology that was built for this lab. What we'll do is to run the script Python. It's in my home folder, script serials. The outputs a list with the actual serial number of switches in my CML. Now we have serial numbers. So we need to modify the topology data model to include these serial numbers for each switch. This will make sure the automation can correctly identify and manage device in the fabric. We'll create a file called topology switches nec.yum. Then the file is a YAML format, and I will need to modify the serial numbers and management information for each switch. YAML is a human readable data serialization format that is often used for configuration file. It is important just to maintain the correct identification and the structure of the YAML file. We have changed the serial number for spines and the leaf. Uh, we'll add border switches to the data model. There are two switches that have to be added to the example data model that are part of this topology. They are border switches that connect the fabric to the outside world. They are typically used for routing and security purposes. So the best approach is to copy the format and paste it into the YAML file. Right, with these steps completed and the rest of the example data model in place, that I can start the process of making network as code push the configuration towards the Nexus dashboard. So far, we have completed some of the steps. We set up an environment, installed Ansible configuration and the necessary files for network as code, Nexus dashboard. And we define the variables required to connect the Nexus dashboard and execute automation is setting up the environment variables. And we created the VXLAN, EVP, and Fabric data model using information from the CML topology and the Nexus dashboard requirement. Uh, Deployment is driven by Ansible. we're going to use playbooks, the YAML file that define tasks. So these playbooks are structured into roles which read the data model and execute tasks to configure Nexus Dashboard. The key roles for network as a code Nexus dashboards are first, well, validate roles. This confirms the data model that is correct and can be processed. And it aggregates the files from the host files into a single model for execution. We create roles is to generate templates and the parameters for VXLAN fabric deployments and create the fabric states in NDFC. Depends on validate the role. Then we deploy the role or push the fabric states to NDFC manager device. It depends on also validated role. We'll remove roles or clean up and manage the states in NDFC and devices control by variables in group values to prevent accidental removal. So take a look at first step is the validate role. Ensures data model is accurate and it will enforce roles to prevent the invalid configuration. It improved reliability. And next is the environment variable. They provide flexibility to different environments and the secure handling of sensitive data like controller credentials. Instead of storing credentials in source code, we're using environment variables. Tools like Ansible Vault can encrypt sensitive data, but here we use environment variable for simplicity. Before proceeding with deployments, it is critical to verify the environment variables that are set correctly. I can do this by just run source.env and env grep nd. Here you go, the username password. And as part of the example repository we have provided is the playbook for deploying network codes next to the dashboard. The file is called vxlan yum, and this is located in the root of cloned repository. That's code server vxlan.yum. To execute the playbook, we're going to run this command. This will take a few minutes to complete. Right. It isn't the order of execution, but rather a summary of tasks executed by roles. So what happened in the background? The playbook execution follows the next dashboard's the methodology. For this reason, there are stages in execution. The two primary stages are creation of fabric states in the next dashboard and deployment of the fabric state to the devices managed by the Nexus dashboard. Uh, if I haven't connected yet to the Nexus dashboard, I should do that now. So what I have to show you is in the fabric controller, we can manage Once inside the fabric view, I can look at the switch inventory for the switches that the network as code Nexus Dashboard has created. You can see my borders, leaf, and the spines, which provides me a list of the switches that are part of this fabric. Okay, so I connect it to the network as a code leaf 1, and it will show run config. Here you go. We have BGP, EVPN, and we'll show BGP L2, VPN, EVPN summary to see the EVPN neighbor. There you go. It matches with our topology. To reach the fabric detail, we're going to close this first. Close this to the management and fabric. Here I can see the fabric settings that have been passed to the Nexus dashboard for network as code Nexus dashboard. For the network, you can see the example, the network being created. As I can see, the example data model included configuration to create networks in Nexus dashboard. I can view this file in data model. Code server, host variable, NACFab, network, NAC yum. These are the 3 networks we created. That's NAC, NAT01, VLAN 2301, 2022, 2003. Okay. Let me explain more about this. The top of a tree will always be VXLAN for this data model. In this case, since we are adding networks, these are part of an overlay. In tree, this makes the topology, okay? Then followed by a list of networks, like the name, net 01, 02, 03. The dash on the networks indicates that this is a list. From a high-level view, I can think of it as a VXLAN overlay network name 01, network 02, 03. This structure creates 3 networks like 01, 02, 03. In this we have attribute required. What attribute is a VIF? This is the name of the VIF that the network is associated with, and net ID is a VXLAN network identifier. What is it? It's a V and I for the network, and the VLAN ID for the network. When I am working with the data model, I can reference the online data model documents to understand the attributes and their usage. So as mentioned before, the data model for VXLAN, EVP, and Fabric is available in this network as a code over the network model document. Each page there is a table available that describes the attributes. Okay. As I can see, some of the attributes are mandatory. In this case, for network, the name is the only mandatory attribute. And I will also see that there are default values for some of the attributes without a definition in YAML file. The default value will be used. Also related to Nexus Dashboard is the concept of a network attached groups. These are groups of switches that are used to attach network to the fabric. In the data model, I define these groups under network attached groups, right? This network attached groups are defined in the example repository. With definition, I can see that example attached group points to leaf one. So this task group define it attached switch to net as code leaf one. So it allow users to define which switch you are using. The VRF configuration that has been deployed by that work at the code Nexus Dashboard. The VRF configuration is defined in data model under the VRF section. So you should see VRF NAC In the same manner, the data model defines the VRF also under the overlay section. The VRF also have attributes that are mandatory and attach groups to define them to a specific fabric switch. The attributes for VRF are defined in the data model in the overlay VRF model document right here. Let's add more networks and VRFs. For this document, we have only used the defined networks and VRFs that are part of example data model. In this section, I will add additional network and VRF to the fabric. This will let me see how easy it is to extend the fabric with the new networks and the VRF. We will open a new file called server host val nac fabric 1 VRF.yam. Okay, it opens the same file. In the open file, I will see all VRFs that are declared, and I'm going to add additional VRF, which is the NIC VRF04, and I will be adding another VRF that is listed under the VRF section here. The dash indicates that this is a list. Each item on the list starts with a dash. Each of VIF in that list is a defined map or dictionary of attributes. So I will you locate last VIF, which is the NAC VIF03, and add a new VIF below it. Say I want a VF attached to all switches because I'm adding it to existing attached group all. I don't need to add it to the network attached to group section. Save that. And we're going to add a new network. For the network, I will be adding the new network is NIC net 04. that's associated with the new VF NAC VF04. Doing the same method as before, I'm adding a network to a list of networks. So these are defined on the overlay section I show you, and the file is network nac.yum. Okay. After NAT seal3, we're going to paste a new name, NAT04 attaches all. I also associate to all attached group, so I don't need to add it to the network attached group. All right, then to deploy the changes, I will run the same playbook as before. So Ansible playbook inventory yum vxlan yum. As you see the output indicating the execution of the automation, and this will take a few minutes to complete. In the end, I should see a summary of the tasks executed and their status. Now, I can verify in Nexus Dashboard controller that new VRF and network have been created. I can do this just by going to the fabric view and check the VRF and network section. And see NAT04 is created, VRF 04 is created. Next thing we'll talk about is removing the role in next network as a code. When I use a declarative model like infrastructure as a code, I don't tell the system delete this object. Instead, I just stop defining it in my configuration. If it is not in my data model, automation will remove it from the network. So how is this different from Ansible's old way? In traditional Ansible, the imperative model, I'd use the state like absent to remove something. And in infrastructure as code, I don't worry about the states like present or absent. I just define the desired state, and the automation makes it sure the network matches that. The example is that if I have a network defined in my YAML file and want to remove it, I just delete the section from the YAML file and the system will handle the cleanup. So why the default doesn't allow removal? To This is to protect the users from accidental deletion, and default setup in Cisco example repo doesn't remove objects automatically. You have to enable that behavior if you want. So the new way, Ansible's new way is to support the declarative models better. So here's the new state. We have merged and it adds your configuration to what already on the device. Replaced is to replace a section of device configuration with yours. And overridden completed the overrides the device configuration for that resources. Deleted is to remove the configuration and reset to reset default. Is similar to how Terraform works. It overrides the current state that the desired state. Due to the collective nature of the network as code for Nexus Dashboard, the developers have taken some measures to ensure that the first-time user does not accidentally remove the configuration from existing development. So by default, the configuration flag is set to false, making network as code for Nexus Dashboard behave in a way to protect from potential mistakes. So inside the create role, automation is heavily reliant on replace the states to offer Ansible module. Only in the removal role does the automation use overwritten and deleted states are used. So in the group file directory, I will find a file called ndfc YAML. Code server, group files, ndfc, ndfc YAML. File is a selection that contains all Boolean flags that control the least module of values to objects in the data model. By default, these flags are set to false, meaning that when I remove an object from data model, it will not delete from Nexus Dashboard configuration. So if I wanted to set this fact to true, then removal of objects from the data model would result in deletion of those objects from Nexus dashboard configuration. So these parameters are tied with parameter force run on. So for first step, we're going to enable delete mode. So I'm going to enable delete mode for network delete modes and VF delete mode. In the file, opened earlier, this file, we're going to change the value network delete mode to true and VF delete mode to true, and we want to save. This we're going to comment out the definition. The data model, I will now comment out the definition of network and VF that I wanted to remove. So we want to do is the VF nectar yum, and we want to comment out name here for VF04. We just add it, and the network for the name to attach group comment out, and we want to lastly run the Ansible playbook. Like we can find the execution completed, and then we'll go back to Nexus Dashboard. VF is removed. VF is removed. Networks is removed. All right, keep next. Network as code testing. Just like software deployment, testing is a big deal.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.